Okay, this is a 4.6 number 16, and this is a growing sand pile. Sand falls from a conveyor belt at the rate of 10 cubic meters per minute on top of a conical pile. The height of the pile is always 3/8 of the base diameter, so we have that ratio that's given. Remember, you always have to have that ratio to solve the problem one way or another, and this is the situation where they give it to you. How fast are the height and the radius changing when the pile is 4 meters high? Give your answer. Now they want you to give the answers in centimeters per minute. So you have to make a little adjustment at the end. So they tell me that it's this pile is growing, so they're pouring onto this pile sand at the rate of 10 cubic meters per minute. So it's coming on here. So we're building the pile like this. Now we have this ratio between the height and the diameter. Okay, so height equals 3/8 d. And remember, diameter is 2r, so the height equals 3/8 times 2r. 2 goes into 8 4 times, so this is my formula for h. So h equals 3/4 r. Now, I'm going to try to solve for two things, h dt and dr dt. So I'm going to find dh dt first. So I'll try to get r in terms of h. Okay, so if h equals 3/4 r, I can multiply both sides by 4/3, so I get r equals 4/3 h. Okay, so again, I'm looking for dh dt when h is 4. Okay, so how fast is the height growing here? Okay, when it's 4 meters high. Okay, so again, volume equals 1/3 base area times height, so volume equals 1/3 pi r squared h. There's our base area. Okay, now again, we're going to change this and get all this in terms of h because we're going to try to find dh dt first. So instead of writing r squared, I write 4/3 h squared. Okay, so then it's just basic. That's it. Then it's just basically some algebra here to simplify this. Actually, just some arithmetic. So I've got 1/3 pi, and that's going to be 16 over 9 h squared times h, which is 16 over 3 times 9 is 27, h to the third. So dv dt equals, and okay, so this is actually volume, 16 over 27 pi, h to the third. So if I take the derivative of both sides implicitly with respect to t, dv dt equals, now this is all constant, 16 pi over 27, and the derivative of this will be 3h squared dh dt. And I can simplify that. 3 goes into 27 9 times, so I've got 16 over 9 pi h squared dh dt. Now my dv dt was given up here. dv dt, change of volume with respect to time, is 10 cubic meters per minute. Okay. This is the constant. Oh, I'm sorry, this is the constant over here, 16. Make sure you bring this one over here. 16 over 9 pi. And h is 4, so that's going to be 4 squared dh dt. That's what I'm looking for. So dh dt equals the 10 multiplied by 9 divided by 16 pi times 16. All right? So I kind of reverse the order so it's to the right of what I'm looking for. It makes it a little bit easier to work it out like that. So dh dt equals, again, multiply by 9 and divide by 16 pi 16, or 16 times 16 pi. So that's 9 times 10 divided by 16 times 16 pi. And that's what dh dt equals. That's 90, and that's 256 pi. Okay? Now that's going to be meters per minute because my original was in meters cubed per minute and meters. H was in meters. Okay, so this is going to be in meters per minute, but I want it in centimeters per minute, so again, you're going to have to carry your units here just to double check. So there's 100 centimeters per meter. So if I multiply this by 100 centimeters per meter, the meters cancel, so I've got centimeters per minute. If I multiply, I've got 90 times 100 is 9,000, all over 256 pi, centimeters per minute. Now I can divide the top and the bottom by 8. 8 goes into both of these, and believe it or not, 8 goes into 9,000 1,125 times. and 8 goes into 256 32 times. So I've got 1125 over 32 pi centimeters per minute. So that's my dH dt. Now I also wanted to find the rate of change of the radius with respect to time. So that's going to be dr dt. Now don't think we have to go through all this over again. Remember we have this relation up here. R equals 4/3 h. So I think you'll like this. R equals 4/3 h. So if I take the derivative of both sides, I'm going to get dr dt equals 4/3 dH dt. Well, I already know what dH dt is right up here. That's this. So I have 4/3 dH dt is 4/3 this, 1125 all over 32 pi centimeters per minute. Okay, 4 goes into 32 8 times, 3 goes into 1125 375 times. So dr dt equals 375 all over 8 pi centimeters per minute. So the B part wasn't so bad because we did most of the work in the A part. Okay. So after the setup, this becomes pretty much just algebra and not too bad. That helps.